Okay, guys, we are going to problem solving. Find the rule. Essential question: how can you use a strategy solve a simpler problem to help solve a problem with a pattern? All right. On an archaeological dig, Gabriel separated his dig site into sections with areas of 15 feet each. There are 3 archaeological members digging in each section. What would the area be of the dig if 21 members are digging at one time? So what do we want to find out? We want to know the area that would be if there was 21 members digging. So what information do I have? I know that there's 15 square feet in each area and that there's 3 members digging. And how many will there be if there's 21 members? Well, I'm going to to solve a simpler problem. I'm going to use this information to help me solve a simpler problem. Now, if I look here, guys, if I just look here, I set up my sections. How many sections did I have? Well, I don't know. I'm just going to keep going until I hit 21. Why? Because I need to know how many members I have. I started off with 3. So if I had 2 sections, it would be 6. If I had 3 sections, it would be 9. If I had 4 sections, 12. 5 sections, 15. 6 sections, 18. 7 sections, I would need 7 sections if I had 21. What did I do? I did 7 times 3 equals 21. So now we want to know, because here's our bigger problem that we wanted to figure out, guys, is how much area. So if 3 people are covering 15 square feet, how much would 6 people cover? 30 square feet. Because I'm adding up by 15. But what am I multiplying by? What am I multiplying by to get this number? Well, I'm multiplying here. I look. 3 times what gets me to 15? 5. Does that pattern continue? 6 times what got me to 30? 5. Yes, the pattern keeps going. So I just have to go to 21 times 5 is what? 105. So what am I doing? I'm multiplying by 5. So how did I figure it out? Possible rules was to multiply the number of each section by 3 and multiply the number of members by 5. So if the area of the dig site is 21 members are digging, how many square feet can we do? We can do 105 square feet. And we figured that all out by writing a pattern. This you really got to draw out, guys, to figure these out. All right, so let's try another problem. Casey is making a design with triangles and beads for a costume. In his design, each pattern unit adds 3 triangles and 18 beads. Casey uses 72 triangles to design. How many beads does Casey use? Okay, let's use a graphic organizer. First, what do we need to know? How many beads does Casey need? So what kind of information do we have? Well, we know that we have 72 triangles, and in each triangle, there are 18 beads. And they are in 3 triangle patterns. Okay, so how can I use this to draw a picture? Okay, so what will my graph look like? So here we've got, what kind of information do we need to know? So this graph, I think, is going to need to know the units. So here's my units. If I have 1 unit, 2 units, 3 units, 4 units, 5 units, I don't know. We'll just start with that. All right, because I have to get, okay, now here's the number of triangles. Here's my units. Here's my triangles. Now I know I want to get to 72, correct? But how many units are in each group? Well, we know there's 3 units in each group. So I'm just going to start there. 3 and how many beads? Now, so here's our beads. And we know that there's 18 beads in 3 triangles, right? So we could keep going. So if this is 1 unit, that's what happens. If there's 2 units, then there's 6 triangles. And how did I get from 3 to 18? I took it times 6. So I'm going to do that here, 36. Okay, 3 units. That's 9. And if you notice, 1 times 3 is 3. So I'm taking this row times 3, and this row I'm taking times 6 to figure it out. And that's 27, or gotta take that times 6, that's 54 beads. All right, so how would I figure out? I could keep going. I could do 4 and keep going, but I kind of know the pattern, correct? 12 times 6 is 72. So I'm just going to go back here and say to myself, 72 divided, because I'm working backwards, I want to figure out what goes here. 72 divided by 3, because I got 3 times what equals 72, so I can divide. So 72 divided by 3 equals 24. So I could put 24 units equals 72 beads, or 72 triangles. So I'll need 24 units. And how many beads is that? 72 times 6. 432 beads. So how many beads am I going to need? 432. So once I figured out the pattern, I took the information that I knew, and you just got to decide. Am I multiplying it, or should I work backwards and do the inverse operation and divide? All right. These are challenging, I think, but I think they're also fun to figure out, but as long as you draw the picture. Yes, I know frustration can come in. Okay, Max builds a rail fence. For one style of fence, each section uses 3 vertical fence posts and 6 horizontal. So here's our vertical. They go sideways. Our vertical is up and down. Sorry, trying to mess you up. Horizontal, like when the horizon comes up, goes that way, and they need 6 of them. And as you can see, 1, 2, 3, and 1, 2, 3, 4, 5, 6. All right. So what do they want to know? He wants to know how many rails does he need for a fence with 27 posts. So first of all, we got to figure out how many posts we're going to need. So for one section, he needs 3 posts and 6 rails. For 2 sections, he needs 6 posts and 12 rails. All right, so let's keep going. What do you notice we're multiplying by? We're multiplying by 3. 1 times 3, 2 times 3. So here we're timesing 3, I'm just going to put. So what's the possible post row? Times 3. All right, if I look down here, the number of rails, it's 3 times what gets me to each one of these? 2. And you know that 9 times 3 equals 27. So 27 times 2 is 54. So what's my possible rule here? Times 2. So finally, did I use the final rule to figure this out? So what did we come up with? How come I'm wrong? Because, oh no, I was right. I'm sorry. 54, I was right. 54. All right, sorry guys. All right, here we go. So we're going to think smarter.
All right, what if another style of fencing, rail fencing, has 6 rails? So we have 6 rails between each pair of posts. Okay, how many rails are needed for 27 posts? Well, we're going to look at our pattern. So here's our section 1. There's 3 posts, 1, 2, 3, and there's 12 rails. So instead of multiplying here, we're still going to multiply by 3. But what are we going to do from here to here? Well, let's look at our rule. 3 to 12 is 4. 6 to 24, that's times 4. So what could we put here? We could put anything here. We could do 5. 5 times 3 is 15. 15 times 4 is 60. What could we put? So how would we figure this out? We just take 27 times 4. And we know it's 108. So we need 108 posts. What's our rule? Possible rule? Times 4. But I could never figure this out if I didn't build the table, guys. All right. So on your own, I would like you and your partner to work together. Look at these. Look harder. Think smarter. Go deeper and figure those out. So go ahead and shut the thing off, and then I will fill in the answers to go back and look at them. Okay, I hope you're back and you looked at your answers, guys. I love these. I would love to have you guys figure those out, find out what the rule is, and figure out how you do the squares. You can get the tiles out and work it if you'd like. It's just good thinking. What I would like you to do for homework is let's do 2 and 3, and 1 or 2, and all the rest.